All right, everybody, let's get started. What if I told you that this is next to the last time that we're going to be together as a group? Ooh, I know, it's getting real, isn't it? All right, okay. Today, what I want to do is we have a quick in-class exercise, and when I say quick, most people in the class got the exercise done before class was over, okay? So I think you can get this one done today. If you can't, it's due Monday by 5 p.m., but I think you can get it done today, okay? So let's go through class logistics since we are really down to the wire. Okay, first off, attendance grades. They are up to date other than today. If you have not yet done so, scan the attendance code because I need it. All right, everything on Blackboard is graded, up to date, current, okay? We have an assignment today, and then we have our assembly and whatnot. I've got a nice little slide here to sort of summarize everything. We have an exercise today, opens today, it closes Monday at 5 p.m., so go ahead and get that one taken care of. Again, I think you'll be able to get it done today. We do not have an in-person class on next Wednesday. I will pre-record a lecture, and I say I will pre-record a lecture if needed. My goal is on Monday to finish the assembly, but I might go through some tips and tricks and some clarifications on how to do that, okay? I want everybody's eyes up on the screen because this, I think, will hopefully be helpful. Okay, so I have here a schedule, which is the, hey, here it is for the rest of the semester, okay? All right, so for our schedule, our remaining schedule, we have an in-class exercise today. On Monday, I'm going to do assembling parts in Inventor. I am going to do a course learning outcome survey on Monday. I'll have another QR code for that. It'll be anonymized and whatnot, but I just want to collect that data on Monday as well. But Monday is the big Inventor assembly day. So for Monday, for the class assembly, I have shown you how to create two of these parts. It would be in your best interest to create the other two so that we can build it all together. You don't need to have the drawings done, but if you have the parts done, that would be good, okay? The week 13 assignment, the one we're doing today, is due Monday at 5 p.m., but I think everybody's going to get it done today. Next Wednesday, a pre-recorded lecture for assembly if needed. Finals week. We are not meeting as a class on finals week. The only thing that's happening on finals week is you have your final assembly due by 5 p.m. on Wednesday, and you have a bonus homework due by 5 p.m. on Wednesday. And that bonus homework is just doing the course eval and uploading proof that you did it. I don't want to see what you said or whatnot, but this is my first time teaching AutoCAD, and I take the suggestions very seriously. So if you have any suggestions for improvement or what you thought about the class, I do really want everybody to do it. So if you do the course learning outcome survey, the course email, I will add 10 points to your overall homework average. So please do that, okay? So at the very bottom, those are the due dates. We have a week 13 assignment due Monday at 5 p.m. We have two assignments due during finals week, the final assembly and the bonus homework. Is everybody clear on that? Everybody clear? Any questions? Okay, all right. One other thing before I pull up the in-class exercise. If you notice this table right here, this table has printouts from the entirety of the semester. I have the homework assignments, and I have the in-class tutorials. I also have copies of the final assembly drawings. If you're missing anything, don't be shy, don't hesitate. Come on up here and grab what you need. After today, I'm getting rid of this stuff, so I wanted to make sure everybody had a chance to grab it. Okay? Sound good? Okay. So here's our goal for today. Our goal for today is to be engineers a little bit and talk a little bit about design. So what I've done is I've formulated a classical problem. This is a plate with a hole in it being subjected to a tensile load. So we're sort of stretching it like a piece of taffy, okay? And the idea is I am giving you 5 materials. I'm giving you ABS plastic, aluminum, brass, steel, and titanium. And from those 5 materials, I have given you both a cost for each of these materials, so how expensive they are, And then I've also given you limits in terms of their performance. So every option has to have a factor of safety greater than 1, and its maximum displacement cannot be bigger than 0.003 inches. Okay? So I want you to create this model, and I'm giving you a handout that'll explain the specifics, but you're going to do this model 5 times, and you're going to record some data, and then you're going to go on Blackboard and quote unquote take a quiz that goes through some questions about it. But ultimately the goal is to pick the right material for the application. The only thing I'll mention that I kind of left out here on the handout, if you look here on the whiteboards, the hole in the center of the plate is 3/4 inches in diameter. And when you're applying the force load is supposed to be in tension. It's supposed to be yanking on the load, not pushing. So when you're applying the load, change the direction of the force. There's a little change direction button there to make sure that it's applying in tension, not compression. Sound good? All right. With that, I'm going to go ahead and start passing these out and have fun. There's space on this handout to write the results of the analysis. So if you got a pencil, that does help. Yes. Yes. It's a really tight requirement. But you'll see what I mean when you look at the data. Bless you. Yes. You're missing one, I'm sorry. All right. So like I said, it's a 3/4 inch diameter hole, and when you're applying the load, make sure you change the direction since it's supposed to be a tensile load and not a compressive one. That actually shouldn't really change the overall results of the problem, that changing direction. You missing one?
No, it's just,
All right, let me get the lights on, and then. Oh, I'm so sorry. That is, when you save it in the MS folder, that is in your OneDrive. I will be right back. Yes.
Hole.
That's what I was putting up here. Sorry. It's a central hole 3/4 inches in diameter. I left that part out by accident. My apologies. the hole should be centered on the plate. There are a number of ways to do that. That part I sort of meant to leave out because I want you to form the hole the way you want to.